Hi guys, Mr. Gillen here, and during this video we are going to talk about simultaneous equations. Two straight lines are drawn. You can see on a graph if there is a point of intersection. What we mean by that is a point where the lines cross or where the lines meet. The point will be a coordinate, so obviously when on the graph itself it's going to have an x and a y value. The way that we can do this is if we're given two equations of lines, then we can substitute into the equations and then we can draw it graphically to determine that point of intersection. We're going to look at that during this video. So, if we look at an example, we're going to try and find the point of intersection of the lines y equals x and y equals 2x subtract 1. So hopefully you recognise them. Remember, the equation of a straight line usually is y equals mx plus c. So we've got the values in there. So we're going to try and find the point of intersection between y equals x and y equals 2x minus 1. In order to do that, we're going to have to construct small tables. So we've got x on the top and then y on the bottom. And all I've done here is I've just given x values. So I've just chosen 0, 1 and 2. They tend to be the easiest ones to substitute into. So when you're forming your table, that's the same thing you would do, just give them 0, 1 and 2. We've got the x values, we need to find out the y values. So we know that the actual equation is y equals x. So if I substitute 0 into my equation, then when x is 0, y equals 0. Do that for 1 and 2. When x is 1, well, y is going to be 1. And when x is 2, y is going to be 2. So what I can say then is I've got three coordinates. I've got 0, 0, I've got 1, 1, and I've got 2, 2. I'm going to do the exact same for y equals 2x minus 1. Notice again, x on the top, y on the bottom, and I've just used the same three values, 0, 1 and 2. So this time I want to substitute x into this equation. I'm going to go to the side to do that. When x equals 0, y equals 2 times 0, take away 1. So y is going to equal negative 1 when x is 0. When y is 1, sorry, when x is 1, substitute it in, same again. 2 times 1 is 2, take away 1 is 1. So like that. And then my last one, substitute in your 2, and we get 3. So what I can do is then, I've now got my two sets of coordinates. For y equals x, I've got 0, 0, 1, 1, 2 and 2. And for y equals 2x minus 1, I've got 0, minus 1, 1, 1, and 2, 3. What am I going to do with those coordinates? Well, I'm going to plot them. So I need to draw myself a set of axes. Then, depending upon what the actual coordinates are, choose the size and the scale of your set of axes appropriately. And then all I'm going to do from there is I'm going to plot the points. So I've got 0, 0, 1, 1, and 2, 2, a line through it. And that's obviously the graphical version of y equals x. And then also draw in y equals 2x minus 1. And we can clearly see that the point of intersection happens here at 1, 1. The last thing you need to do is just state, if the question asks you to state the point of intersection, then a wee comment at the end, the point of intersection is 1, 1. That's all from me just now. Thanks very much for listening. As always, if you've got any questions, please don't hesitate to get in touch. This is Mr. Gillen signing off. Speak to you all soon.